This session today, aptly titled Studying Snow and Fire, is going to take a look at two hazards prominent in the American West, and that is avalanches and wildfires. And I think that these topics, while they're sort of oppositional in terms of temperature, have a lot in common in terms of the way we imagine and think about the risks of our landscape here in Montana. And so I think, again, it's a really apt pairing. Our first speaker today is Alex Miller. And Alex is a PhD student at MSU in Bozeman. He also holds a master's degree from CSU in Colorado, Fort Collins. And Alex is sort of special to me for a couple of reasons. I also study avalanches, and so there aren't a lot of us out there, historians studying avalanches, and so it's been really nice to get to know him the last couple of years and see his work evolve, and it's just really great stuff he's been doing. He's now moving more towards looking at other types of environmental history in the West, recreation history, but I'm glad to have an ally in the field of avalanche studies. He's also special because he is the winner of our Emerging Scholar Contest this year. This is an annual contest put on by Montana, the Magazine of Western History. This, I think, is our 4th year of doing it. And this was something that is really dear to my heart as the editor of the magazine, because we really want to encourage emerging scholars, graduate students, and early career historians to publish their work. And of course, we love it when they publish it in our magazine. And so encouraging those submissions. And I think, he now joins an elite few in that he was the winner this year. So we're really glad that he can be here to give his talk. His, I should sidebar, his article is also in the Autumn magazine this year. So if you have a copy of that, I hope you'll take a look at it. Alex's talk today is called From Studies to Centers, Evolution of Avalanche Research in the West. Alex?
Hi, everyone. Thanks for coming to this panel. I'd also like to take a minute to thank Diana and especially Jeff as well for all their work getting this article published in this issue. In 1953, U.S. Forest Service Snow Ranger Montgomery Atwater, this man pictured right here, said, "There's no possibility that exposure to avalanche hazard in the United States will again decline." He was right. In that year, the number of avalanche fatalities was 3. This last winter was 27. And this graph illustrates an upward trend of avalanche fatalities between that time frame. 27 also isn't the highest number, 37 is, which is just emphasizing how much this has become an issue in the West and an environmental issue in the West. But when Atwater says the avalanche hazard, he's not talking about the number of avalanches that occur in the West. He's talking about the overlap between humans and avalanche terrain. And as a U.S. Forest Service snow ranger, it was his job to mitigate this hazard. So what is an avalanche? It's essentially a very scary cascade of snow, ice, and debris on steep slopes. Happens anywhere there's slopes and mountains. So the Mountain West has a lot of those. New Hampshire, for example, on the East Coast also has avalanches. And they occur when an overwhelming amount of weight, be it from a skier or excess snow, breaks a slab of snow, which a slab's a cohesive layer of snow. I'll say this word a lot. It really just means a bunch of snow that's formed one big layer. Snowpacks are not uniform. So slabs form on weaker layers or stronger layers, and it's this interface between these two layers of snow that creates an avalanche. History of American avalanche research is a story of connection to community and to the landscape. The spark for professionalization of this field was U.S. Forest Service funding following the advent of alpine skiing in the West. With a growing standardized set of knowledge, researchers expanded their community into a robust yet dispersed community that emphasized environmental knowledge creation and communication to the public. So the history of this field is making extremely localized observations developed in the mountains, and then repackaging these for public use and for spreading this knowledge to the public. In doing so, it blurs lines between urban and rural and lab and field research. So observations link mountain towns and urban areas in new ways, as I'll continue to explain. And until the field really began to mature, it was all field research. Similar to my advisor's research on mountaineer scientists in Victorian era Britain, these people had to be comfortable working in really extreme climates. But they constantly communicated between fields, labs, or what field labs is kind of like what the early era of scientists were doing. So there's a fluid flow of knowledge that's being created and communicated among each other and to the general public as the field grows. But the tether to all this is avalanche country. So anywhere there's snow and mountains. Avalanche fatalities aren't a new issue to the West. As Diana's book gets into, there's a long history of people encountering avalanches in the Mountain West. Early scientific knowledge was informed by miners and railroad workers living in the mountains and experiencing the avalanche hazard firsthand. So data wasn't looking at an avalanche and going over and checking it out. It was losing friends and losing family members or having near misses that you can go home and tell a story about. The early framework of avalanche knowledge is one of avoiding mountains after heavy snowfall. That's what these people just through living in the mountains noticed. If you do have to go to work, go to the mountains if you're a miner, travel in groups, or just take safe routes, avoiding avalanche slopes. And as this picture on the left illustrates, if an accident does or if a disaster does strike, there's a full community effort to help find people to restore property. But with the silver crash in 1893, this knowledge largely left the mountains, and it didn't reemerge until urban visitors began entering the mountains as skiers in the 20th century. So why is there a link between the U.S. Forest Service and skiing? That seems kind of random. In the 1920s, a growing leisure class started demanding that our public lands, national forests, start developing recreation opportunities for 3 seasons. In Colorado, the Forest Service began developing trails and roads up mountains to facilitate these urban visitors to national forests. But if you're in 1920s Denver in the winter, you still want to go in the mountains. It's right there. It's probably kind of smoggy in Denver at this time. So the Forest Service began developing ski areas on national forest land. In 1930, famed ski jumper Alf Engen did a survey of these intermountain national forests to find potential ski areas. His favorite place that is pictured on the left was Alta, up Little Cottonwood Canyon outside Salt Lake City in Utah. So by creating this like crown jewel proposal for the Forest Service up a steep mountain canyon that has a history of avalanches, the Forest Service knowingly created the avalanche hazard that we have today. And so they had to figure out how to mitigate it. This started in 1937, 1938 winter with the hiring of the first avalanche observer, C.D. Wadsworth. His role with the Forest Service was to monitor weather, snowfall, and any avalanches that happened at Alta. But he wasn't doing it quite to protect skiers yet. He was protecting the people building this chairlift pictured on the left. as you can imagine, 1938 is kind of a busy year in the world. So avalanche research through the Forest Service was kind of shelved until after World War II with the hiring of Montgomery Atwater. Atwater himself was a 10th Mountain Division veteran, so he experienced avalanches in the European theater. He writes about seeing, I'm not sure if it was Swiss or someone in the Alps using artillery to trigger avalanches, which is now a common practice in the US. It took some work to get the Forest Service a howitzer in Utah. He didn't really use artillery much until started working with the Utah National Guard in the 50s. But as a snow ranger, his role, again, was to mitigate this hazard and then also to kind of create common practices for other snow rangers at other ski areas. So while he was at Alta skiing, closing trails if there was a hazard, monitoring weather conditions, and organizing rescues if disaster did strike, he was also recording all of what he was doing. And this culminated in the Alta Avalanche Studies, which was a manual, US Forest Service manual for other ski areas as best practices in the role of snow ranger. So he talked about all he was doing, but he also established early uniform ways of identifying an avalanche danger. So contributory factor analysis is this uniform way that is still used today in a different iteration. So he was able to look at old snow, new snow, wind direction and speed, and factors related to mountain climate to identify if an avalanche hazard existed. And if it did, then he would close ski runs if it threatened other people. That same year, 1949, Swiss mountaineer and snow scientist Andre Roche came to the United States and did a survey of all of the Western ski areas. This was, again, kind of consulting to establish best practices among snow rangers and among Forest Service managed ski areas. But he introduced this idea of climate zones, which snow in Oregon, Washington is different from snow in Utah, is different from snow in Colorado. Related to elevation, moisture, and all of these things, which creates distinct avalanche hazards in all of these regions. This inspired a growth in the field because before this survey, they were just looking at avalanches at Alta. But field expanded to both Colorado and the West Coast in Stevens Pass, Washington. So Washington's snow is a lot denser. It occurs at a lower elevation. And because of this, avalanches occur way closer to storms. Alta is a higher elevation. So the snow is a little lighter, creates different avalanche hazards there. Berthoud Pass, Colorado, and Colorado mountains in general, their climate zones characterized by high elevation, sparse snowfall, and a really dry and windy climate, cold in the winter. And this creates some unique avalanche hazards that Forest Service want to examine. So at Berthoud Pass, researchers were examining this deep slab avalanche issue, which, again, a slab is just a layer of snow. As the name infers, a deep slab is when this layer of snow is really deep in the snowpack. So if an avalanche occurs in this situation, all of the snow on top is involved. So as you can imagine, this creates these really big, violent avalanches. So observers were looking at this issue in Berthoud and communicating their findings back to Alta to, again, grow this field and continue spreading this knowledge from dispersed areas. And this is illustrated through what they started looking at Alta as well. So the second generation of avalanche researchers in the 1960s there, namely Ed LaChapelle and Ron Perla, they were both looking at slab avalanches at Alta and the snow they form on. So they're not necessarily examining these deep slab issues in Colorado. They're speaking with Colorado researchers and seeing what they can find in their landscape. This culminates in Ron Perla's The Slab Avalanche, which, similar to the Alta Avalanche studies, was just a way of creating a uniform way of talking about this phenomenon. So he created a report that helped identify slabs and then created common terminology to talk about them. So this picture on the right, after this article came out, if a researcher says bed surface or crown, other researchers in other areas know what he's talking about. However, they were supposed to be doing administrative studies in Alta, so creating these reports. What they largely were doing was field research and skiing. Which, I mean, if you're tasked with creating this field and growing this knowledge, you're going to do it from going out into the snow and seeing what you can find. Forest Service didn't like that, and they cut their funding in 1971. And so the field then shifted from Alta as its hub to Fort Collins at the Rocky Mountain Research Station, because that was already a facility that was meant to be doing Forest Service field research. This creates kind of a strange thing, because instead of avalanche knowledge being developed in the mountains and staying in the mountains, it's being developed in the mountains and then leaving to be stored in Fort Collins in new information technology and databases, and then being analyzed and projected back to the mountains. So this is, again, this growing fluidity of knowledge about avalanches leaving and coming back to the mountains. At the same time, the field expands to universities, which is, again, a better venue for doing the basic or field research that they were doing at Alta. Ed LaChapelle worked a lot with University of Utah professors in his time at Alta. He went on to work at University of Washington as a geophysics professor. Again, doing the same research, but at a different venue. At the same time, Charles Bradley and John Montaigne began to gear Montana State University's Earth Science Department towards snow studies and snow science in the Bridger Range down outside Bozeman. There's also an international expansion at this time. So LaChapelle is trained in snow science from Switzerland. And so he's translating a bunch of Swiss texts and then spreading them through the Alta Center when it was still around for other researchers to see what Swiss scientists are talking about. Before LaChapelle, there was kind of a rift between American and Swiss researchers. American researchers, because we have these 3 climate zones and this huge landmass of the Mountain West, didn't think that there is much to be gleaned from Switzerland's tiny landmass and uniform avalanche issue. I also suspect Atwater held some potential bias from Switzerland's neutrality in World War II, just from the way he talks about like Swiss scientists. To actually talk to the man would be interesting to see his thoughts. But this changed with the second generation. So information age technology begins playing a much larger role in avalanche research at this point. Again, observations are being made in the mountains, and then they're being phoned into Fort Collins to have analysts and Forest Service specialists look at this data and make forecasts, issue warnings, things of that nature. And this is done through two major projects. The first is the Alpine Snow and Avalanche Research Project, based out of this office in Fort Collins. This is the project that Alta's funding was reallocated to. And what they were doing in this project was recording mountain weather, continuing to publish reports and handbooks, and also expanding the network of weather stations around the Mountain West in Colorado to better examine mountain weather throughout mountains. Two notable researchers that I'll mention a lot moving forward came from this project. Arthur Judson is a veteran researcher at Berthoud Pass, and Knox Williams was his mentor. The second project is the San Juan Avalanche Project. It was organized through Colorado University's Institute of Arctic and Alpine Research, or INSTAR. And it was headed by Ed LaChapelle, working in cooperation with them out of University of Washington. So again, this is this expansion to universities doing work as well. They were also setting up weather stations in the San Juan Mountains down in southwest Colorado. You can see on this map here. And they're also examining how wind affected snow and how cloud-seeded snow in the San Juans affected wildlife and infrastructure. So LaChapelle worked on a Department of Defense cloud seeding project, which was just during the Cold War creating stores of frozen water in the Colorado watershed. Along with LaChapelle were two of his mentees, Betsy and Richard Armstrong. And so this marks a new generation of researchers. So there's Atwater, LaChapelle, and Perla, and then this new generation of people that are coming up through universities or new into the Forest Service, bring diverse perspectives and information technology to the field. And this is kind of told through the relationship of these two pictures. So these two photos are from Arthur Judson's Avalanche Warning Program in Colorado, which is a conference paper he presented in 1977. So this person is in Fort Collins on the left, and this is a weather tower outside Berthoud Pass. Excuse me. And this shows this connection of mountains and lowlands and this constant communication of avalanche conditions and knowledge. So what began with Alta circulating reports evolved into this database this man is adding to and analyzing on the left, called the Westwide Network. And what the Westwide Network did is it stored weather data and avalanche information from the 42 weather stations throughout the West that they're building at this time. The goal was to have just a store of data to look back on and kind of see where avalanches continually happen, what weather conditions cause them to happen. At this time, they're issuing avalanche warnings. And Judson understood that avalanche forecasting is all about statistics and probability. So he wanted to have as much data as he could to produce informed forecasts. And these forecasts are what is being issued to the public to keep them safe. So again, this is this repackaging of knowledge to the public. The San Juan project also highlights this relationship. So in this project, they were pairing weather data and observations on the ground to see where avalanches were happening. Through this, the Armstrongs noticed that wind transports snow at a much faster rate than snow can fall, which creates much more weight and coherent slabs, which then break into avalanches. So by looking at wind direction and speed, you can start predicting where an avalanche might happen. This is noteworthy in the San Juans because Highway 550 in Colorado goes right through the mountain range. It goes over 3 mountain passes and a lot of avalanche terrain. And before this observation, they would just close the road when an avalanche happened. So if you're a driver on this road in the winter, then that's extremely dangerous. But afterwards, after noticing how wind affects avalanches, you start seeing anticipatory closures. And so these observations being made in the mountain are now directly impacting the safety of people driving in Southwest Colorado. And again, this illustrates the growing communication between field and lab and the expansion of this community throughout different landscapes. And this is what an early avalanche warning looked like through the Colorado Avalanche Warning Program. So Judson would issue these text warnings to the National Weather Service to be relayed to people throughout the West. They're extremely localized. So it says Southwest Colorado mountains. He'll list which mountain ranges are included in a hazard, or excuse me, in a warning. And by going through the National Weather Service, it's then broadcasted to TV watchers, radio listeners, and people with VHF radios. In the 1983, funding was also cut to this program. This is the era of austerity among federal agencies. So the Colorado Avalanche Warning Program was no longer funded through the Forest Service. The same year, though, Knox Williams and Betsy Armstrong founded the Colorado Avalanche Information Center, which continued this work and really emphasized Judson's vision of communicating all of this to the public and making sure that the public is aware of what's going on in their states. And the CAC was the nation's first state-specific avalanche forecasting center. Now there's forecasting centers in every Western state and some Eastern states. I forget the exact number. But this is the current model of communicating avalanche hazards to people in the mountains. So the history of American avalanche research, story of connection and community, connection to community and landscape. This was fueled by a post-World War II stubbornness that wrote off Swiss research, making the mountains really the only place that Atwater can glean knowledge from. With the standard set of knowledge, researchers expanded their community. And using this robust community, researchers continued to build an understanding while communicating their findings to the public. So this is an ever-evolving field, and while new knowledge is being formed, it's being communicated to people involved. Today, volunteers at trailheads spread avalanche awareness and skier safety, and avalanche forecasts are shared through interactive maps in a user-friendly way. So on the right is an example of a current forecast from the Colorado Avalanche Information Center. You can look at a map that shows every mountain range in the state and a specific forecast for each range. But through all this, you see a consistent through line from old mining days. Still, the best way to stay safe in avalanche country is to avoid the mountains after a heavy snowfall, travel with friends, and stay safe while you're traveling, make smart travel tactics and decisions. And if disaster strikes, help out. It's an ethic among backcountry skiers that if you see an avalanche, you go over and help to make sure no one's caught in it. And this is a direct through line from the old mining days. Thank you.